Hello everyone, welcome back, and in this section we are going to look at the code part of visualizing movie scripts. So let's connect our Google Colab notebook. So once you are connected, run this cell so that even the Google Drive where all our files are stored is also connected. Now once we are connected, let's install our libraries. Here we are installing all the necessary libraries. The first one is sentence transformers library. We are going to use sentence transformers library to convert our movie plot into a vector. Although it is called as sentence transformers, you can give any individual word or paragraph or sentence and convert it into a fixed vector of size 768 or 364, etc. And text wrap is basically just, as we have seen, library to just visualize the text without scrolling. And umap learn is another interesting library. As we have mentioned, we need to do dimensionality reduction to convert, let's say, 768 numbers into 768 dimensional vector into 2 dimensions, etc. And so umap learn is the library that does the dimensionality reduction for us. As discussed previously, umap is superior to tsne, which is superior to pca. Now let's install this. This is simply because Google rolled out a new update, and because of that update we are unable to display progress bar and other IPython widgets within the Colab notebook, so just for that. And let's go ahead and start with our usual stuff, which is loading our movie plots file and then just printing all the things, just the data frame. Once you're done with the data frame, let's actually get into the sentence transformers code. This is how you can import sentence transformer, and you can create a sentence encoder model like this. So you can give several names here, and I usually prefer this if I want to do faster as well as good vector interactions. But if you want to go for higher quality but slower generation, you can go with all MPNet base v2 as well. Simply put, if you are looking for the highest quality, go for all MPNet base v2. If you are looking for a trade-off of speed and accuracy, go for all mini LM v2. For demonstrations purpose, this is best for us. We can run it quickly and see. So run this cell. Awesome. Let's drop some duplicates, since we have seen that there were few duplicates. And here what we are doing is to convert all these plots into a list. So there are almost 3379 plots, and everything is converted into this plots list, and we are just printing the first one. The Jonathan Rivers is an architect, etc. And what we are going to do here is we are going to pass this list of movie plots that contains 3379 items, and this sentence encoder model that we just initialized. This is all the code that is needed, so it's not too complex at all. And once you have that, you are just passing this movie plots list to this sentence encoder model and calling the encode function, and it is going to generate the embeddings of all the movie plots 3379 that are here. And it will take a little bit of time. That's why we have progress bar is equal to true. So you can see that it's splitting it into batches. So 3379 is split into 106 batches, and estimated time at the moment is 7 minutes or 8 minutes, somewhere there. So not too bad. We can just wait until this finishes, and then we can look how the embeddings look like. Awesome, we are done with the embeddings encoding. Let's look at the first embedding and its length. As you can see, the model that we are using generates embeddings of size 384 in length, and you can see all the values here. So this is pretty much it. What sentence transformer does is it takes in any sentence. So this is for the first movie plot. The whole movie plot is converted into this vector of 384 dimensions. That's what this is. And what we are doing here is to create a data frame with embeddings attached to the plots. Essentially, we have our movie name, Wikipedia link, plot, and now we have created embeddings for each of the movie plot, and we are just attaching it into the data frame as well. And what we are doing here is actually invoking UMap to convert this embedding of 768 dimensions into a lower dimensions of size 2. So here we have some hyperparameters for UMap. All you can do is import UMap and UMap.UMap fit transform. This is where you give all the embeddings that we calculated as a list, and then you can give metric cosine, using which you can find the distance between two embeddings, etc. So this parameter n neighbors controls the local neighborhood that you want to consider, how many points need to be included in that, in the graph construction, etc. And n components is simply how many dimensions you want to reduce it to. For example, here we are reducing it to 2 dimensions, and if you want to visualize in 3D, you just need to keep 3 here. And minimum distance also is a parameter, how densely you want to pack points together, etc. It's also a hyperparameter that you can control, and you can look more at all of these hyperparameters and what they mean, etc. at this link. But essentially, we are giving our embeddings and we are asking it to convert into a 2-dimensional embedding for each, and we are giving n neighbors as 5 and mean distance as 0, and cosine is the metric that we are using. And let's run this. Awesome, we are done with this. And again, once the embeddings of 2 dimensions are calculated, we are just appending it into our original data frame as the last column. So again, you have movie name, Wikipedia link, plot, full embeddings, that is of 364 dimensions, and this is the 2-dimensional embedding, that is dimensionality reduced using UMap. Now all we need to do is take these 2-dimensional embeddings of UMap and visualize them, as well as showing the metadata of movie name, Wikipedia link, etc. So for that, we are going to use Plotly. So Plotly is a very easy to use library, and here you are giving all the data frame columns here and stacking them, because you have 2 values and you want to create a 2-dimensional plot, x and y plot. That's what you're doing here. And once you stack them, you want to just isolate all the x values and y values separately. That's what we are getting here. X and y are lists of these values, and you are just creating a scatter plot, 2-dimensional scatter plot with our data frame as input, and you have x and y that are there, and hover data. So once you hover over a point, what's the data that you want to show and what's the name. So you can choose to show some metadata here. That's what we are giving here, hover data and hover name. It's an interactive plot. Once we run this, it will be very evident. Awesome. As you can see, it's an interactive plot. You can just scroll through and see this is Harry Potter and Half-Blooded Prince, and there is Wikipedia link, and you're showing the x and y plot. So You can easily see how different movie plots are grouped together and see what are the outliers for our purge and the purge election year. And the other thing is, since it's an interactive plot, you can actually zoom in on here. For example, the purge one, you just need to do this and you can keep zooming, and there are almost 4 or 5 points in this. So purge the anarchy, purge the election here, the purge, forever purge, first purge. You can see beautifully that all these movies are clustered together here, and we have not done anything apart from using sentence transformers among these 3600 movie plots to cluster all the purge movies together. But automatically you can see that they are clustered together just by using sentence transformers. That's the beauty of this. You can identify clusters, you can identify any outliers that you see, etc. And let's create a data frame column where we are appending the type as movie, because soon you will see we are going to append another type called as directors, and we can simultaneously visualize both by using different colors. It will be very evident for you in a bit. And what I've done next is, if you go to this link, I have collected the first page where 100 American directors and their description is listed, and you can see that every director has some description here. So I collected the director name as well as description by further going into this link. If you further go into this link, there is this description that you can see. So I collected all of that. I used parse hub like we have seen in the earlier lectures to do the same, and let's just visualize that. Awesome. So you have the first one, then selection URL and biography. As you can see, Stanley Kubrick and the URL and the biography. And what we are doing here is converting all these directors' bios into a list again, and we are encoding all these director bios just like how we have encoded the movie plots. One thing to remember is that when you simultaneously plot these two things, which is directors and movie plots, the content of a director is kind of different, where they are born and other things, etc. They don't directly relate with movie plots. When you try to find similarity, still you can get a fair estimate. Let's just convert all the director bios as well into embeddings. Awesome. Now we are able to convert all the director bios into embeddings as well, and we can see it here. So the director name and URL and biography and full embeddings. Now let's append a last column as type director. Where we're going to do that is we are going to combinedly visualize both movies and directors on a single plot and find similarities. That's why we are appending this type as director. Now let's go ahead and just do some renamings, because these are directly from parse hub and they don't have the name that we are looking for. So we are just renaming the selection name to name and this to link, and we are just ignoring this, and we have full embeddings and type. That's what we are doing, this renaming and just using the 4 ones and ignoring the biography. Let's run this and see. Awesome. Now you have director name, link, full embeddings, that is the 364 dimensional embedding, and the type as director. Why don't we do the same with our movie plots, where we rename the movie name to name and wiki link to link, and also just keep the columns that we are looking for. So here we have again name, link, full embeddings and type for movie. So now we have got both the director's data frame as well as the movie's data frame. looking similar with similar column names. And now all we can do is just combine these two data frames since they have the same names. Let's do that. And this is the combined output, as you can see. So the type, there are movies and director, as you can see. Since the number of directors is less, we don't have that many entries in what we are randomly seeing in 25 samples, but you get the point. So basically the name, it's a combination of movies combined with director names. Then you have their corresponding links, either it is an IMDb link of the director or the Wikipedia link of the movie. You have the full embedding, 364 dimensional full embedding, and you have type as movie or director. Now you can go ahead and just get this column of full embeddings into a NumPy array. We are going to see why do we need that. Simply we need that because to the UMAP dimensionality reduction technique, we need to pass this, because we are going to convert this 364 dimensional vector, we are going to compress that into a 2-dimensional vector, and it is going to do dimensionality reduction taking all the data points, 3400 plus data points, that is combined with directors and movie plots, and it is going to preserve the local and global structure and do the dimensionality reduction. That's what is happening here. Let's run this. So this is UMAP embeddings 2-dimensional combined for this data frame above that contains both movies, movie plots as well as director descriptions. Now we are going to add another column to the data frame, which is just the 2-dimensional data points. As you can see, we have name, link, full embeddings, type, and now we have a new column that is UMAP embeddings 2-dimensional, that is the dimensionality reduced version of this 364 dimensional embedding into this 2-dimensional embedding. Awesome. We can go ahead and now visualize both of these things, and we can color on the type parameter, that is the type column. So it is going to associate 2 different colors depending on what are the different kind of values present under type. And we again give our combined data frame as XY plot, and we have our plot values extracted as X and Y, and we are just giving that. And again hover name and hover data is what we are giving here. So let's run this and it will be very evident. Awesome. Now you can combinedly visualize both movies as well as directors in the same plot, as you can see. But as I mentioned, the director bios or descriptions are quite different from the movie plots, because they talk about where they are born and their trajectory as they are evolving into a director, etc. So most of them are kind of like clustered in a similar zone. But the interesting thing is we can just hover over a few things. For example, let's zoom in on this area because it has Joker and Batman Begins, etc. Let's zoom in on this area, and let's zoom in more. So we see a director, Frank Miller, and this is the link imdb/nm05888340, and we have other movies of Batman that are nearby. So Batman, Joker, some Dark Knight, Batman vs. Dracula, Batman Begins. So all the Batman movies, and along with that we have the closest point, Frank Miller. So what's happening here? Let's go and see actually Frank Miller's biography from the same link. So it says his great success came with DC's character Batman. In 1980, he wrote the acclaimed Batman story, Wanted Santa Claus Dead or Alive, for DC Comics. In 1806, his most notable comic book, groundbreaking Batman Dark Knight Returns, etc. So he has quite a lot to do with Batman and Dark Knight, etc. That's the reason why he is very close to all the movies. Now we know that Batman Begins is directed by Christopher Nolan. I was not aware of Frank Miller at all, but just using this visualization technique, I know that Frank Miller already worked on Batman movies, etc. back in the 1980s and 1986. So you can immediately see, for example, if you have a new movie plot, you can immediately see who are the closest directors that are in red. And also the thing is that this is an interactive plot, so you can just uncheck directors and check them back, or you can uncheck movies and check them back, so you can do visualization overlays. The beauty is that you can give even more things here: movie, director, actor, and other things. And simultaneously, let's say you have a new movie plot, you can find the closest director as well as actor and any other casting. If you visualize all of them in the same plot, you can immediately on the dashboard of visualization itself see for a given movie plot which director is best suited, which actor is best suited, and all these things, etc. So we have not done any customization here, but you see the magic that Frank Miller is automatically associated with all the Batman Begins movies. And similarly, if you look deeply, you can extract relationship between other movie directors as well as similar movies around him or her. The beauty of this approach is that you can use this approach for pretty much anything. For example, matching startups with professors and research labs. For example, you can plot all the startups and their descriptions, as well as research labs and the work that they are doing. And you can think about collaborations between nearby startups and research labs that are nearby, or professors nearby, and they can do work collaboratively and publish research or work on new products, etc. Similarly, you can if you have a job board site, you can plot all the job descriptions as well as resume content of the candidates, and you can immediately see for a given job description which candidates are close by, or the vice versa, which is for a given candidate which are the closest job descriptions that he or she can apply to. So there are many uses with visualization. You can immediately identify outliers, you can do a high level overview of the data, you can bring any new movie plot or job description or candidate description, and you can identify similar jobs or similar directors in this case, etc. So you can do quite a lot of things with visualization. And thanks for watching. I'll see you in the next section.